Historically, there's tons of data we as engineers and scientists collect. We're always measuring and monitoring things. So there's always been a lot of data that is at our fingertips. And with the advent of the smart grid and all types of energy control systems that are now out there, this data has really increased exponentially. And the real-time project team is mining it for environmental benefits.
A parallel that I see between the real-time energy monitoring and EPA's real-time air quality data is that it allows the user to see what the current situation is and to adjust their behavior in response to that. And it is very important for us to have the public as a partner because the future will be working with new technologies, and control of power plant emissions is an important component of improving air quality.
Power plant emissions have a very important impact on the health of the Great Lakes. So there's certain types of pollutants coming out of the stack associated with each of the generators. And our technology allows us to pinpoint a particular pollutant that's important to us. So for instance, if mercury is of most importance, I can schedule my energy use in such a way that I bypass the times when a power plant that may be spitting out more mercury than may come at another time when a different generator is providing that demand. So this technology allows a person or an industry to basically dial in to what their values are regarding certain pollutants. The real aha moment is really an understanding that 1 kilowatt hour of energy at a particular time is not equal environmentally to 1 kilowatt hour of energy at another time or at a different location. So our team is taking advantage of that through incorporating new technology into the design of scheduling systems for water systems, industrial systems of many types, or building automation systems.
Detroit Water and Sewerage Department is committed to going green. So the biggest consumer of the energy is our pumps. They range from 100 horsepower to 6,000 horsepower. In Dr. Miller's software, what it provides is it gives us a recommendation on out of 170 pumps, what pump is the right size pump that we could use to lower our energy usage. We have looked at the real-time modeling as a great opportunity. We didn't have any tools, and even in the market, there was no tool that would provide that kind of real-time pump optimization. So the goal here was to pilot it at DWSD and then replicate it for other utilities, because we're one of the largest water utility. So if it works here, we're pretty sure it will work in other utilities.
Siemens is a global leader in the energy and power generation segment. And we see a lot of potential in the private industry for being able to offer our customers not only the ability to reduce energy consumption, but also reduce emissions. Dr. Miller's real-time program is bridging a gap between power generation and smart buildings as to how we utilize the energy, and allow the customer to tailor his system to reduce emissions while saving money.
The real-time energy management team is a great fit with our search here at the Protection Fund for projects that have order of magnitude consequence in the world. This project in particular is trying to find ways where devices talk to devices. It's something that draws on the big data that's available on the grid, and they can pool that data, have it talk to a device, let's say a refrigerator, so that the refrigerator uses the most power during the times when cleanest sources are available. There were 9.5 million refrigerators sold in 2010. This is a non-trivial strategy. This is a big deal because changing the timing from dirty power to clean power reduces the footprint on the Great Lakes. It can turn down mercury, it can turn down lead, it can turn down sulfur oxides and nitrogen oxides just by shifting the time of that use. It's the first time anyone's done such a thing. And this was a key attractant for us, is that it's built around what the Great Lakes need. So this makes the power grid transparent to the lakes need transparent to the consumer, and puts the consumer in charge of aligning the two. It's really cool.
So the real crux of our project is the ability to give consumers of energy the information about the emissions that are created by using the energy at that point. And so the system is much more transparent, and people can actually make decisions based on the environmental integrity of the generation that's being provided at that point in space and time.